Morning, everyone. It's Eric Christie, Boxer Inspections. We're at a new construction foundation pre-pour foundation inspection today. So we got another video in the series. And what did we see at the inspection today? So I've talked about these before, but I want to give a little bit more in depth on what's going on with these types of inspections, things that I check for, and other stuff that we look at when we do these types of inspections. One of the things that's super important when we do this is to be able to have the engineering drawings at the location so that we have something to reference. So otherwise I can just collect a bunch of dimensions and I don't know if they're right or not. So, and I'll be clear and I always tell the client that, and most builders are pretty good about that and letting you have the drawings, but there's some that don't. In this particular case, the builder was kind enough to leave the drawings over here attached to this rod, and as he put it, in a plastic bag. So it's a piece of the plastic that's here. The drawings are wrapped up. And of course they're dirty, muddy, wet, and torn and stuff like that. They're in pretty bad shape. But I think I got enough information of it. On this particular note, I'm going to bring this up and deviate a little bit from the foundation inspection. We'll talk about electrical here. This is what's known as a concrete encased electrode. What they're doing here is they're taking this rod, and they have to have a minimum of 20 feet that goes along the side of it that's attached to it that provides a ground. What the National Electrical Code states is you must have 25 ohms between the ground plane of the bus and the main panel to earth ground. The only way to get that is to measure that. If they can't get 25 ohms measurement from it, then they have to install a second grounding rod and then have a grounding conductor connected to it. So in this case, this is what they're using. However, there is an exception in the National Electrical Code related to this, and it says in locations where a plastic barrier or some sort of moisture barrier, vapor barrier, which is put on the soil before the concrete is poured, negates the requirement that has to be buried in the concrete, and the concrete must be in direct contact with the soil. And it says specifically, if you have some sort of vapor barrier on the soil that's in between the soil and the concrete, it is not assumed to be in direct contact. You can't do this. So every one of these types, I find that, I write it up. I know a lot of other inspectors do. The electricians always say, oh no, you guys are misunderstanding it. That's not what it says. And I said, well, it's only 2 sentences, so it's not really hard to misinterpret that. But that's for the builder and the electricians to do it. They sign their names on it. But anyway, let's get back to this inspection. We're talking about this. As I said, this is a vapor barrier, plastic that's put on it. Need to make sure it's taped and sealed. We look over here, we see not only some trash in the form that we don't want, but we also see a big gaping hole in the side of it. So why does that need to be sealed up? We don't want groundwater seeping into the foundation after the fact. Always find out that spot's wet or moisture issues, or if it's in the house, then that can certainly cause humidity problems and mold growth and things like that, but we're not going to get into that. The other things that I check is I'll look down here and I'll check these beams. This is a beam. They run across the house and along the perimeter, and they go both directions. So we end up with these pad sections, that's what I call them, pads. And the depth of this, I check the depth, I check the width at the bottom. So when we look down in here, there's a couple of post tension cables in there, and they go both directions in this particular beam. Sometimes they don't. Sometimes there may only be one. In this case, they have two. Spacing has to be correct, which is usually about 2.5 inches. And then I'll check the width at the bottom. In most of the drawings that I see, we look at is about 12 inches is the bottom of the beam width. In this case, the drawing says 10 inches, so that's what I'm looking for. And then the top of it, also measure the top where each of the two pads come together. So if I can put my finger there, like right up, ooh, that's not working. Okay, right here to right here. We're checking that width and seeing if it meets what's on the drawing. So they use typical, so that's what it should be pretty close to, plus or minus maybe whatever is on the drawing. Have to look for that as well. And then I also measure the height of these tendons, the cables, from the bottom of the beam. And then what I like to do is get my 100-foot tape measure out, and I'll go ahead and put it over here at the very front of the house and run it all the way to the back. We'll measure the length of the property, or the length of the house, and then also measure the width of it, make sure that everything is squared up. Usually measure at 3 points so that we know that there's not any sort of variation in the forms, which they're typically not. But then I'll go to each one of these tendons and I'll measure them from that distance. There's my finger. So up here in the front, it's focusing on my finger. So we'll measure it from the front of the house and measure each one of those tendon locations going down the line, and then each one of the beams measure that to the center point, because each of those are defined on the drawing by the civil engineer that designed it, or structural engineer that designed it. And so I check all those going this direction, probably about half of them, and then do the same thing going across the house any other direction. So those are good measurements to take. Following that, I'll come over here, I'll look at the beam depth here, make sure that they're maintaining it all the way around the house. We're also going to check make sure that they maintain the grade along the side of the home. Let's step over here. And I tell you what, folks, it can be treacherous walking on these things, especially when they're wet. So here they've done a pretty nice job. I usually don't see this kind of dirt work around here, and they actually, kudos to these guys, they actually put plastic on the bottom to help prevent water from draining into the forms. So that's pretty awesome. That's like the second time I've seen that. So that's a super bonus for these guys. So we'll give them some extra brownie points. And then one of the things I noticed, that they're supposed to seal the edges of our vapor barrier that's on here, and they're using this material, which is Kingspan. I've seen this stuff before, and I went to the website and looked at the manufacturer's recommended applications, and they said nope, can't use it on the soil on the something that's going to be in contact with moisture. So this is not an approved application of this. So in this particular case, they've used that tape, and they've also used duct tape on it. Duct tape is usually what I see. Duct tapes manufacturers, they don't prohibit this application, so I guess that's fair game, even though that I don't think it's quite a good application for it. But bottom line is they need to be sealed. The green stuff is no bueno. We're going to write that up and let them know. You see all the pipes sticking up? Those are all the plumbing penetrations, bathrooms, kitchen, and vent pipes that you see. And then one of the other things that we're going to have problems with probably in the next day or so is that it is supposed to rain here, and I don't know when they're not going to pour concrete in the next couple of days. And tell you what, folks, walking on these forums can be a little treacherous, especially when this plastic's wet. And let's get up here to the front, show you something else. Listen to the guys singing over there at the construction site. So this is a drainage channel. So if there's water in the forms inside in the trenches and stuff, beams, that's supposed to drain out here and head on out that direction. But that means that all of these beams that you have out here, they're all supposed to be sloped up to the front so it can get here. And I can pretty much guarantee you that that is not happening. A lot more difficult. Something else that's kind of interesting about these this particular builder, they've done a pretty good job. We'll give them some extra points here. Their beams are actually pretty straight. So a lot of what I see, especially in the tract home builders and stuff, is you'll get a little bit of waviness in the beams. Beams are supposed to be straight. It's part of the structure of the home, and so we want those to have some basically some structure and stuff to them. But in this case, they did a good job, and we'll give kudos to them. So this is a long video. Like I said, we're at the 8 minutes or something like that. I hope you guys have watched the whole thing, learned something from it. These are really cool videos. I think give you a little bit better understanding of what the foundation looks like. And for me, this is one of the most interesting inspections that I can do. So this is Eric Christie with Boxer Inspections. I hope everybody has a great day. If you need help with phased inspections, if you're building a home, call me, 281-783-3030. Everybody have a wonderful day and enjoy your weekend.